Here's a video talking about irrational roots in polynomials with rational coefficients. All right, we've been playing with quadratic equations for a long time, and the quadratic formula has helped us a lot. But have you ever noticed that they've come in pairs, these solutions to quadratic equations? For example, this is a quadratic equation. If you use the quadratic formula, you get this, which really is just shorthand notation for two different answers. And notice they're exactly the same except for the sign in front of the square root. But it's almost like they're twins, they're pairs, they come in a pair. The reason this happens is because of the coefficients of the polynomial, of the original polynomial, are rational coefficients. A is 1, B is 3, C is 1. Those are the coefficients and they're rational. There's no square roots in them. And that's always going to happen. The key thing is when you do have such a polynomial, and again, it has to have rational coefficients. If one root is irrational, there's got to be another one. They come in pairs. And the only difference is going to be the sign in front of the square root. So if you know that you've got a polynomial with rational coefficients and it has a root of negative the square root of 7, the key thing is that's irrational, which means the square root is what makes it irrational. You know, it also has its pair, its twin, except one's positive and one's negative. That's also going to be a root. So here's an example. You're told that you have a polynomial. It's third degree, so you know there's going to be 3 roots with multiplicity. And you're told it has x equals negative square root of 7. You're told it has x equals 3 as a root. But since it's got rational coefficients, you know it's got to have another irrational root. It also has to have a square root of 7. They come in pairs. The only difference, again, is the sign in front. So here's the work for answering this question. You know that you've got a root of 3, which gives you this x minus 3 factor. This root is going to give you actually this factor, and this root gives you this factor. Let's multiply this out. The way we did that is FOILed. And this is really nice. See how the middle term cancels out? That's where the idea of why there's pairs in the first place. The middle term is always going to cancel out if they come in pairs. And then I'm going to distribute again, FOIL again. And there's my function. The only thing I've got going on here is this a. And that a in front, the leading coefficient, we're going to figure it out with the fact that p of 0 is 5. So when you plug in 0, you end up with just 21 times a, which means a is 5 over 21, and you've got your answer. So that's how we attack these types of problems.